Is g of x continuous at x equals 1? Well, it could be. That's one of our answer choices. Answer choice B is that the function g of x does not exist at 1, therefore it's not continuous. So we would have to check to see if g of 1 exists. The next one would be the limit of g of x as x approaches 1 does not exist. So the question is, does this limit exist? If it does, then it could be continuous. If it does not, then that could be the answer here for the reason that it's not. Or does the limit of g of x as x approaches 1 equal g of 1? If that is not true, then answer choice D will be the correct answer. If this is true, and the other two are also true, then it would be considered continuous. So let's actually examine our piecewise function that we have here. And we're looking for when x equals positive 1. So the question is, does g of 1 exist? Let's look. Okay, so we do have when x equals 1, it is a defined piece. So g of 1 does exist, therefore answer choice B can be completely ruled out. Now let's examine what the limit is of g of x as x approaches 1. First we have to do from the left, and then we will also have to do this from the right. So first from the left, that would be in this third piece. We can substitute 1 in here. 1 minus 1 squared, which is 1. So that would be 1 minus 1, which is going to be 0. Okay, so that's what the limit is for g of x as x approaches 1 from the left. Now let's approach our function g of x from the right-hand side. So again, we can substitute our 1 value in here. We would have 2 times 1 minus 2. Well, that's 2 minus 2, which is also 0. So therefore, the limit of g of x as x approaches 1 is indeed 0. So this does exist, therefore, because this limit exists, answer choice C can also be ruled out. Now let's see how the limit is in regards to the function value. Are they equal? Well, the limit of g of x as x approaches 1 is equal to 0. G of 1 is negative 2. So therefore, these two are, this equation, is not true. These two have completely different values. So therefore, g of x is not continuous at x equals 1, or answer choice D.